We are going to go through how to use your calculator to look at the graph of a function and the derivative of a function, and if you want the second derivative of a function. We've talked about this in class. This is your reference if you need extra help. So first thing to do would be to enter the original function f of x into your calculator. Okay, and then I have a derivative of my y1 set up here, and the key is instead of at x equals a number, you put as x equals x. We're not going to graph it yet, but we leave it there. And if you wanted to, you could even do the derivative of y2. Okay, and the question of the hour, where does y come from? Vars for variables, and then y variables. And so then I could have that be the second derivative. It's going to be really slow, but it does allow you to look at all three if you want to. So I'm not going to put it in there yet. Careful where you hit enter, you get to change what your graph looks like. So if you leave it unhighlighted, it won't graph. All right, so I'm going to graph the original function. I can do the calculus here and find what f prime is, but I just want to use my calculator right now. So I hit graph. This is a normal window. It looks like the function is going down here and turning around. I need to change my window, so I'm gonna make my window go a little bit less x, and I'll make the y go a lot narrower or a lot lower, and see if that helps how we're seeing it. And so I can see, I want to be able to see all of the turnaround points. I'm probably going to go ahead and make the x even a little bit less, just so it zooms it in a little bit more. So you can see the function's coming down here. There's a minimum. It's all concave up right here. Somewhere here it turns a concave down, shelf, and then it's heading on up forever. So if you want to see, that's the graph of the original function. If you want to graph the derivative so that you can compare values, the derivative should cross the x-axis wherever there's a max or min. So right there, it's going to cross right here. That's a shelf. And so we've been talking about looking at the graph of the derivative. If you want to hide the original function and just look at the graph of the derivative. And the way I was highlighting that is by hitting enter. So when we talk about on the original function, what's going on here? Well, the original function is decreasing, 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 0. Increasing, increasing, increasing. I think there's a turnaround here, so that would be an inflection point. Decreasing, 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 0, increasing. So if you put that original function back on there, you can see that happening. It's decreasing all the way to here, where it's 0. Right up above, you can't see it. If we change our window, we can see it a little bit more. Right up above, there's an inflection point going on. Okay, I'm gonna go ahead and make this window go a little bit higher in the Y area so we can see it. There we go. So there's the original. Derivative takes a little longer because it's got to calculate individual values. Again, though, lining up where there's a horizontal tangent, there is going to be inflection points located at those places, right here, right here. So if you want to make things really interesting, who doesn't want to do that, you could graph the second derivative. I don't play around with this, but you can make this be a different type of shading. I'm hitting enter. See if it'll make that one a dotted line. So we got the first two on there. Second derivative should be coming in. There we go. and you can see what is common. When the second derivative is 0, we have a horizontal tangent of the first derivative, and we have an inflection point. And when the second derivative, you can see where the first derivative and the second derivative are both 0, that's when we have a shelf.